Naslednjo predstavitev bo izvedla doktorica Floriana Coppola. Floriana je doktorirala iz kmetije na Univerzi v Bologni. Pred 2 letoma se je pridružila Laboratoriju za dediščinsko znanost na Fakulteti za kemijo in kemijsko tehnologijo Univerze v Ljubljani kot štipendistka Marie Curie. V raziskavah se osredotoča na negotovost, povezano z modeliranjem razgradnje in neinvazivnimi analizami materialov kulturne dediščine. Predavanje bo potekalo v angleškem jeziku, predavanje pa lahko zastavite tudi v slovenščini. Floriana, I've read the presentation you so beautifully delivered. The floor is yours.
Okay, thank you, Damiana. Thank you very much. Well, sorry for my voice, first of all. Not my best voice. I hope that it will last till the end of the presentation. Well, the dating method I'm going to present is a non-destructive method based on chemical information that are analyzed through statistical tools. As you know, it can be quite common to find documents that are undated in libraries and archives. Specifically, it has been estimated that tens of thousands of undated documents, paper books, manuscripts, documents are preserved in libraries and archives. Actually, there are interpretational methods to date a document, and these include aspects like style, the provenance, references to eminent individuals or events, the handwriting, or the type of paper, so the type of carrier, watermarks, and so on. Sometimes even dames and men may assist with dating, at least within a date range. A recent approach, for instance, based on the analysis of watermarks, reported very encouraging results for dating incunabula, but also etchings, like the study I report here, carried out on Leda and Swan by Raphael, or this one carried out on Rembrandt's etchings. There are numerous other techniques that can be used to date paper. Now here we come to analytical methods, and maybe the most well-known example is radiocarbon dating that has been extensively, and actually is extensively used in archaeology, anthropology, geology, but it has some limitations for the more recent wood-derived papers. This method, as you know, is based on the determination of radiocarbon. And for more recent objects, we have the so-called bomb peak that is used. The so-called bomb peak that you can see here is a strong increase in radiocarbon concentration in the atmosphere due to the nuclear tests carried out during the Second World War. However, in case of wood-derived fibers, that, as you know, is most of the paper produced from the second half of the 19th century, the procedure for dating paper using radiocarbon is not straightforward, because the radiocarbon content that we measure is an average of the value from the different tree rings. So each one of the tree rings has its own radiocarbon concentration that is characteristic of the year of the growth. So to estimate the age of the paper, we would need to know the age of the trees that have been used to produce the paper. And you can see how difficult it can be to get this information. And here we come to our approach. That is, we make use of an analytical technique that is named near-infrared spectroscopy. And as mentioned before, we use this chemical information through statistical tools that are named machine learning methods. Now, to develop this method, we have to provide two different data that are the publication date of the book. So we find the publication date of the book, and then of that book, we measure near-infrared spectrum. Maybe you have already heard near-infrared radiation. And usually it is associated with the red colors. Here we can see the visible radiation, which goes from blue to red, and then it comes to the near region. And this is the region of interest for our approach. Now, without going too much into the details, to measure spectra, so to measure the information related to this region, we simply put this probe light on an object of organic nature, in our case, a paper book, and molecules start vibrating and in a particular way. So we can measure how they vibrate in this region, and these are called near-infrared spectra. Now, the problem with this kind of spectra is that it's kind of complicated to interpret these spectra as they are, and that's why we need statistical tools. For instance, let's get a look at these two groups of spectra. These near-infrared spectra have been acquired for a book dated at the end of the 19th century. And these spectra have been acquired for a book dated at the end of the 20th century. And actually, we can see how difficult, I'm not able to distinguish between these two groups of spectra. And so only looking at these spectra, I'm not able to distinguish if a book is dated at the end of the 19th or at the end of the 20th century. And for this reason, we need statistical mathematical tools to see if these spectra include information that are useful to distinguish between these two books. Therefore, to summarize our approach, once we have provided and we have collected the publication date and the near-infrared spectra, we used machine learning methods, statistical tools, so that we can date paper only using spectra. So we can date an undated paper document only based on the information of the near-infrared spectra. This approach has already been done. However, with our study, we tried to answer to the following question. First, how accurate can we be in predicting the publication dates of books in the period 1851 to 2000? The second question concerns the process that underlines the prediction. Let's suppose that we are able to date paper using this approach, but we can assume that dating is enabled by the changes in the methods of manufacturers of paper, like, for instance, the presence of inorganic compounds or the accumulation of degradation products, like, for instance, cellulose oxidation. And so here we come to the third question. To what extent paper degradation or paper variability, meaning compositional changes, influence the dating model? And to answer these questions, we followed some main steps. As mentioned before, of course, the first is to acquire data, so data collection. Then we moved to data analysis, and then we focused on how accurate we are, so uncertainty evaluation. As far as data collection is concerned, we analyzed 100 books dated from 1851 to 2000, as mentioned before, from the general collection of the National and University Library of Slovenia. We acquired the spectra according to this design. So for each book, we measured 10 different pages, 3 pages from the front, 4 pages from the middle, and 3 pages from the back of the book block, because in this way, we try to address the variability of paper within the book. As we know, pages of the same book can come from different paper batches. And so in this way, we try to address paper variability within the book block. On each page, we measure 3 different points. We measure the inner margin, so the gutter, the center of the page, and the outer margin of the page. In this way, we try to address paper degradation because we know that the margins, the outer margins, are expected to be more degraded than the center of the page because the outer margins are exposed to pollutants and light. Then, as mentioned before, regarding data analysis, I will not go into the details, but I would just like to mention that we used 3 different statistical methods. Partial least squares, PLS, that has been most commonly applied in this kind of studies. Then we used 2 alternative approaches that are random forest and kappa nearest neighbors. And we can see that if we use PLS to predict the publication date, we have an error of 12 years. If we use random forest, we have an error of 5 years, while if we use KNN, we have an error of 2 years. So, especially because we got such different accuracies, we wanted to explore if these methods give importance to different variables in the spectra. And so, with this plot, we can show that actually, regardless of the method that we employ, the most informative ranges are the same, and the most important spectral features, the one that you can see here, the peaks, are typical of cellulose and protein structure of the paper. As mentioned before, another aim, another question of our study was to assess whether paper variability has an influence in this kind of dating method. And so for PLS, random forest, and kappa nearest neighbors, for all 3 methods, if we look at the bars, we can see that the errors are comparable. So there is no meaningful difference if to develop this method, we use the spectra acquired on the front, on the middle, or on the back pages. There is no difference because if we compare the errors with the error bars, these are comparable. The same happens for degradation. So if we look at the bars, the errors are comparable, meaning that there is no significant influence that we can associate with degradation. So there is no difference if we use the spectra acquired in the center of the page, the least degraded area, or on the other margins of the page, the more degraded area. However, and this is interesting, because if we look at the difference of models, now I put here only the results for KNN. If we look at the difference of the models developed using spectra acquired on one page, but several points, but if we compare these results with the models developed using the spectra acquired on several pages of the same book, but only on one point, we see that there is a meaningful difference. So at the end, we can conclude that the spectra acquired on several pages of the same book, but only at one point of the page. It doesn't matter if it is the inner margin, the center, or the outer margin. It doesn't matter. It's beneficial for our model. So it's good to acquire spectra on different pages of the book, because in this way we can address the paper variability within the book block. So to quickly summarize, our results show that 2 out of the 3 machine learning methods that we used, PLS, random forest, and KNN, allow prediction of publication date from near spectra, so from chemical information that we can acquire in a totally non-destructive way, with an accuracy of up to 2 years. Then, regardless of the statistical method that we used, we have seen that the most informative wavelength ranges, so the most informative variables, are common and can be associated with cellulose and protein structures typical of paper. we found also that degradation does not meaningfully influence the prediction, because we have shown that the models developed on the more degraded areas, so on the margins, do not meaningfully differ from those developed on the less degraded areas. Future work should include testing of the model performances that we got using independent test sets. If you want, you can find more details of this research in the paper that we published in the Journal of the American Chemical Society. And lastly, let me acknowledge the National University Library for the support for this case study, Dr. Jasna Malisic and the staff of the library for having facilitated the study, assembling the books to be analyzed, and of course, all the others who took part in this research. And of course, you. Hvala za vašo pozornost.